coefficients for, remember this one, a0 plus a1 x1 plus a2 x squared plus a3 x cubed. And some of them might end up being 0, some of them might not, but we're not sure yet. A4 x4. And that equals sine x divided by cosine x. But of course, if I do a little cross multiply, cosine x would come up here, and that would just equal sine x if I multiplied this by cosine x. Now you're going to write it in your notes the other way, so I'll just keep writing. Cosine x from our formula booklet.
We only need the first two terms.
Yeah. So we'll look at it. We'll figure out which ones we don't need in our multiplication in a second. Over 2 factorial plus x4 over 4 factorial. Well, that's given. This is cosine x from the formula booklet. That's continuing. And sine x from the formula booklet, I've left myself very little space to write this. X minus x cubed over 3 factorial plus x5 over 5 factorial, and so on.
Sorry.
Yes? No.
Is there a way to do this using the
Hence?
series we've gotten? Because it says hence.
Yeah, that's what I'm saying. Hence is shown in the mark scheme. This is the otherwise.
Is this easier than that?
I think we've done so many of these that this should not be too hard. Yeah.
The first one is cosine.
I think they actually differentiate in the other one. Yeah.
Is the first one cos?
Yeah. So this is what I've called tan x. This is what I've called cosine x. This is cosine x from the formula, and this is sine x. So those multiplications, left-hand side, much equal right-hand side. How many do I need? I only need the first 2. So that's sweet. Well, let's look at our first multiplication. A0 times 1. So let's look at the constants. A0 times 1 equals 0. There's no constant on the sine x. So A0 is 0 if it ever comes up again, A0. Okay, let's look at the x terms. This one times 1. A1x times 1 is equal to... Is that the only time that would happen? When I multiply this by this, that gives an x squared. Yeah?
Yeah, that's the only time I think.
Yeah.
It's just increasing.
Equals x. C.
So A1 is 1?
So A1 is 1. Okay, so we got A0 to be 0. We got A1 to be 1. Remember, we're trying to fill in this.
We only have one term right now.
Or not. Yeah. So we got one term so far. So we need... let's look at the x squareds. There's a possibility we might need to go to x cubes. Probably, yeah.
A2x squared times 1 is...
So a2x squared times 1 is definitely 1. What is there another one? Yes, a0 times this. But a0 is 0. But we put it in anyway, just so we don't forget. a0 times minus x squared over 2 factorial is another one. Is there any other way of making x squared in these multiplications? So I've done this times this, and I've done this times this.
No x to the 3 on the cosine.
No, I think they're the only 2 ways I can get it. And what does that equal over here? Nothing? There's no x, 0 x squareds if you want to put in.
Nothing on the A0 side either because it's also 0.
Yeah, so this is 0.
And so that's probably also 0.
So therefore a2 has to be 0 as well. We see that? That's a pretty quick jump if you're not following that. Maybe you can expand this and you'll see that a2 is also 0 because this is 0, then that has to be 0. Okay, and now we go to the x cubed, and I think this is the last one we need to do. How many ways can we make x cubed? This one times this one. So we got a1x times negative x squared over 2 factorial. Those 2 multiplied will give negative x cubed over 3 factorial, won't it? Just double check there's no other way. Oh, there is one more other way, isn't there?
A3x times 1. A3x cubed times 1.
A3x cubed times 1. Yeah, this one. There's one more.
That's the one I'm doing first.
Oh, sorry. Yeah, all right.
That's the one you normally jump to.
Ax cubed x times 1. And that equals, sorry.
It doesn't give you an A3 if you don't use that one.
Nope. All right, so that equals, I skipped that one. So there's two different ways of making that. A1 we know is 1. A3 is really what we don't need, or we don't know yet. So let's just work out this. I'm going to leave out all x's from now on to solve of this. I might do it over here. Just going to leave out the x's. So this becomes minus 1, this whole thing, minus 1 over 2, sorry. So minus 1 over 2 is the coefficient here. The x cubes don't matter because we knew they were x cubes anyway. A3 plus 1a3. And that equals minus 1/6. And then we can find A3 from that. So A3, then if I add this over here, so it's 1/2, yeah, it's 2/6, so it's 1/3. So A3 is 1/3. Have I found enough terms? Yes, because I have A1. I know there's not this term, that one doesn't exist. A2 doesn't exist, but we have something here and something here now, so that's enough for me. So it is x plus x cubed over 3. They're the first two terms. So I just put in x, 1 in here and 1/3 in here. And they're my first.
Just over 3? Right.
Yeah, I don't need to. I can write 1/3 x cubed as well. Okay. That's that one. I don't know if that's easier. I'm almost. Oh, I have the mark scheme here. What am I saying? How do you do A? Remember, minus sine x is the same as sine minus x, and you put minus x in. Yeah, so it's 1.
So you just substitute
Yep.
minus x
Yep.
in the top one.
Yeah, they use the derivative of ln cos
And
x.
then B, you have to use the angle identities to multiply 1 plus sin x by 1
Okay.
sin x.
Let's look at part D in our, when I looked at this first, I said, well, this is almost certainly L'Hopital's rule, but you know what, it's not.
It's not.
No. So what's tan x squared? What's that?
It's 1
Just like that, sorry.
x.
And what's the ln, was it ln cosine x? Ln cosine x. We had these earlier on in the question, somewhere. Ln cosine x is there in part B, so I'll write that down. X over 2 squared minus x over 2 squared minus x over 4 over 12 and so on. And then the tan x squared is, did we get tan x?
We have the x plus x.
Oh yeah, so we have this, now we have put x squared in.
And I think we have to keep going.
So that's x squared over plus x4, x, that's terrible, x6 over, oh, don't do that, over 3. So I put x squared in everywhere there was an x. So that became x squared, and that one became 2 times 3, which is 6. Okay, and we want to find the limit of this as it approaches 0. So this is, yeah, you start to think, okay, well, if I just sub in 0 and 0 here, I'm going to get,
A whole lot of nothing.
yeah, I'm going to get nothing over nothing. So you start thinking of derivatives. Whenever you start thinking of derivatives, you're still going to get
A whole lot of nothing.
forever. If you keep deriving it, you're going to get the same because those x's are the same powers, aren't they?
Yeah.
So the next one would be an x over x, and then the next one is going to be constant over constant. But we can get there a lot faster. If I just divided, like if you ever saw x squared all over, or let's say 2x squared all over 3x squared, what would you write?
Sorry? 2 over 3.
That's 2 over 3, yeah. So what's the first, if I divided both, took out a common factor of x squared out of both of them,
1 over a half
1 and a bunch of x's,
over a
negative a half and a bunch of x's. And now sub in my 0. These bunch of x's go to 0, but we do have
1 over
a limit,
which is negative 2.
-2.
That's it.
That's it.
That's a 4-mark question.
Yeah.
Crazy.
Not because, but it's because you,
Because you have to think about it.
yeah. Well, you did have to sub in the x squared first, for a first step.
What a tedious process.
I know, but like, which means you would have had to get this right. But there was follow through, but you mightn't have got it with follow through.